Good morning, everyone. First of all, I would like to thank Centric for organizing this wonderful event so they gave us the opportunity to be here and present our papers. Today I'm going to talk about one of our pilot tests. Before I start, I would like to thank my co-authors, Mr. Sharif University, the project manager, Ali Kusti, our division manager, and also Odor Control Group, the assistant director of LA. Also, I would like to add Vlad or Lorenzo, our colleagues who have always helped us day to day. They have been very helpful to us here in our village. The topic of my presentation today is about City of Los Angeles pilot test on a suspended carbon vessel design. Before I start, I want to give you a brief background about wastewater collection system in City of Los Angeles. In City of Los Angeles, we have a huge network of collection system. As you see here, this is the map of major sewer lines in City of Los Angeles. We have around about 6,700 miles of sewer lines, about 150,000 manholes. We have like 4 wastewater treatment plants. You see here, this is the DCT, LAG, and the Hyperion here, very close to the LAX, and another one close to Long Beach. And these facilities are for wastewater treatment. For air treatment and odor control, we have 13 facilities around the city. 3 of them, so here you see that 3 of them, these red circles are air treatment facilities which use biocirculating filter along with the carbon as a polishing unit. 10 other facilities are carbon scrubbers that are these yellow circles that are all around the city. So also the site visit tomorrow is going to be one of our air treatment facilities, which is located here, NC Forest. After this brief introduction, I talk about the objective. So as a result of these several facilities that we have in the city, we always try to improve and optimize the performance of these facilities. These pilot tests, we had a couple of objectives. 2 main objectives that we had was first to evaluate the performance of a new technology that was introduced to us. The new technology that we are going to talk has a suspended carbon media, which provides extended surface area of carbon, and also in addition to that has a mechanism to remove the moisture. So the first objective was to evaluate this technology, and also the second objective was that to compare the performance of new technology with our existing carbon scrubbers. Before I talk about the pilot test, I want to talk a little bit about the carbon. How does activated carbon works? If you look at the carbon media closely, like we see something like this. Carbon has high degree of porosity. When you push the air into the media, the air goes to the porous space, these void spaces here, and because of the electrostatic absorption, the forces between different molecules, H2S gets trapped in these pore spaces. And that's how H2S gets removed from the air. And as we push more air, gradually these pore space gets filled, and that's when we need to replace the media. So this is briefly how it works. The problem, one of the main problems that we have in our facilities is moisture or water. When water gets to the carbon, it's like a poison. Somehow it kills the media. It fills the space here, then we don't have any room for H2S to be removed. Then we try our best to make sure that water doesn't get to our media because it's almost impossible to dry the carbon after it's wet. This is the schematic arrangement of units for our test. We had like a test, a 500 CFM traditional carbon, like similar to the existing units that we have in the city, and also we had a 500 CFM vessel designed with the all-around flow manufactured by AFRA. So the technology that we are going to explained here is from the AFRA, so they can visit their desk here in the company. So we got the air from the treatment plant from in Hyperion, from the primary tanks in the Hyperion, then push the air in both units. And the important thing in this comparison that we are doing today is that we should know that the exactly same air with the same quality is going to both of them. Then we can do the comparison. These are the pictures of our units. You see here, this one is the traditional one that we have. These are the inlets. This is the new technology that we use. This will be the suspended media, and this is the outlet, a new outlet. You see we are getting the foul air exactly from same location. How our traditional carbon scrubbers work? You see here, for our traditional units, we get the air from the primary tanks, then we push the air to the vessel. We have multiple layers of carbon in our tanks. Because of the pressure, the air goes to the carbon media, and H2S is removed, and once we have the clean air, the clean air goes out. One of the problems that we have in this technology is that because of the contact between the carbon and the ball here, condensation happens at the contact between the carbon and the ball, and once we have the water, that water goes into the media and gradually tries to fill up the porosity of the media, which results in losing the performance of the media. That's how it works, as opposed to this one. Okay, sorry. And this is the picture of the existing carbon scrubbers that we have in Hyperion. So just an example of to see how they work. And since I said in these mechanisms, these traditional units, they don't have any mechanism to remove the moisture. In these units, when you look at the exhaust here, sometimes we clearly can see small drops of water is pushed out from the unit. And that's important to know that a lot of water is going in those media, which is very harmful for the unit. The new technology that we are using, the AFRAS technology, the scrubber looks like this. In this technology, the media inside the vessel is suspended. Then we send the air to the vessel, this chamber here, we pressurize this vessel, and then air from all around the suspended media gets to the carbon. This mechanism provides extended surface area of the carbon, which increases the performance of the unit. In addition to that, when we push the air to the media, to the vessel here, there is a plate here. Because of the impact between the air and this plate, so the condensation happens here, and a big portion of the moisture in the air gets removed here. So here, before air gets to the media, a big portion of the water is removed, then it helps to extend the life of the carbon. So later on, the next slide, we see the comparison. So the big features of this new technology, as I mentioned, is increased surface area of the carbon and mechanism to remove the moisture. Okay, we started our pilot test on October 14, 2015. Both vessels were installed on top primary channels at Hyperion, side by side, as I showed the picture. And we evaluated the performance of both vessels based on the removal of H2S, VOCs, odor level, and also we measured the amount of water which was captured from each vessel. Okay. Let's talk about the result. This graph shows the H2S removal efficiency for the traditional carbon vessel, the existing units that we are using in City of Los Angeles. The blue line here shows the concentration of H2S at inlet. This is what we get. This is the foul air from primary tanks. The green line is the outlet of H2S, and you see it's almost zero. And the red line at the top here is H2S removal. The percent of the removal is here. You see, when you start the test, it shows 100%, almost 100% removal until this point. At this point, we see a decline in the performance, which at this point, we decide to replace the carbon. You see here, after 4 weeks, somehow the porosity of the carbon has already filled up with H2S. It's not working perfect anymore. And it shows that the lifespan of the carbon in this technology is 4 weeks. After 4 weeks, we are losing the performance. This is for total non-methane hydrocarbon removal for the same unit, traditional one. The same trend is observed here. So the concentration of the total non-methane hydrocarbon in ppm is the blue line here. You see we have a variation between like 5 and 40. The outlet is almost zero for the period of like 4 weeks, but after 4 weeks you see the removal line starts to decline, and that's the indication of the carbon is already filled up with the odor compound, and we need to remove that. Now, as to compare the result, we are going to see the same result for the new technology that we use. So here, we observe that after 4 weeks, we see the decline in the performance. But this one is the H2S removal efficiency for the AFRAS carbon air, the new technology that we use. Again, it was a suspended solid, and all in addition to the moisture removal mechanism. We see the trend here. This is the inlet. The blue line is the inlet of the H2S in ppm. And on the other side, we have H2S removal in percent. You see here, we see almost 100% here. And like after, the difference here is that we see the decline in the performance after like 7 weeks. So again, I want to mention that we send the same air to both units. Both units had same type of carbon, coconut shell virgin carbon. The only difference in these two units was that in one of them the media was suspended, and also we had mechanism for moisture removal. Here we see that we after 7 weeks, so we had 100% performance for 7 weeks, and after that we had decline in the performance. Same thing for total non-methane hydrocarbon. You see here we had like 100% removal for a period of about 7 weeks, and here you see that after 7 weeks, like there is a drop, which is the indication that media needs to be replaced. So far, you see that the performance was longer with the new technology, AFRAS carbon scrubber. With the same carbon, we have like 70% increase in the life of the carbon. Other difference between AFRAS unit and the traditional one was the mechanism to remove the moisture. So we decided to capture and measure the amount of water was removed from each vessel. So here you see that the blue line is the amount of water captured from the traditional unit that we have. You see here it's very small number, and the average measured was 1 fluid ounce of water. Very small amount of water. But as opposed to this one, you see the orange line here is the water collected from AFRAS unit. You see the significant difference between the amount of water was removed from each one. Again, since we send the same air to the both units, here you see that the water which was collected here in AFRAS unit was not collected here. It means that this amount of water every day was going through the media. And as I explained earlier, the water, when it goes to the carbon, it fills up the pore space and somehow kills the carbon. And that's why here you see that the life of the carbon in traditional one is shorter than the life of carbon in AFRAS technology, because in addition to the H2S, the pore space gets filled up with the water. And again, here you see that this is the breakthrough for each technology. Based on the removal, after 4 weeks, we observed the breakthrough for traditional, and after 7 weeks, we observed the breakthrough for the new technology being used. The summary of results that we had is H2S and VOC breakthrough detected after 4 weeks on traditional one, while it was detected after 7 weeks on AFRAS vessel. So daily water collected from drain of AFRAS vessel, as I mentioned, was about 54 fluid ounces, while the traditional vertical vessel only collected 1 fluid ounce. That was the huge difference in the amount of water. Also, we did the test on the outlet of these units for the odor detection threshold and recognition threshold. We took samples on 2 different dates, November 4 and November 18. We took samples from inlet and outlet of each technology. So the inlet was very high, so the max is 60,000. So this one we say 60,000, and this one is in the logarithmic scale to make sure that it's visible. So the orange one is the AFRAS one, and the gray one is conventional carbon scrubber that we have. You see here, both of them are really good. Before breakthrough, you see both of them are working very well, but even though both are good, you see slight difference between these two, and shows AFRAS is a little better in performance in odor treatment. And on the second one, you see here, inlet was like 11,000, and for the AFRAS was 130, and 750 for the traditional one. And it's good to mention that the second sample here we took was after observing the breakthrough in the conventional one. So as I mentioned earlier, after 4 weeks of test, we noticed there is a breakthrough in the conventional one, and somehow it was not working very well. That's why here you see that this one here is much larger than this one. And the reason we can say why this 130 here is like larger than this one, because the carbon here is 2 weeks older than the other one. So as we keep using the carbon, so the more space gets filled up. And because here the carbon is 2 weeks older, we see a little decrease in the curve. This was the odor detection threshold, the same result for the recognition threshold. So the inlet 60,000 was 60,000, and for the second sample was 5,100. Again, here we see that even though both of them are really good, there is a little better performance in the AFRAS one. It's only 25 here and 35, and again 55 here on November 18, and 370 for the traditional one, which was after observing the breakthrough in the scrub. So I'm going to show a video here. This is the water collected from the AFRAS. Yeah. Collected 54 ounces of fluid every day, and in traditional units, this amount of water every day goes to the carbon. That is like a poison for the meat. Here, every day significant amount of water was captured and removed. Without that technology, this water would go to the carbon and fill up the pore space of the meat. And that was one of the significant differences between these two technologies that helps to improve and increase the life of the carbon. So as a conclusion, we can say that both vessels are doing good as long as they have not reached their breakthrough. Both of them are working very good, almost 100% removal. But the difference was that for traditional units, it was only 4 weeks, while for the new technology, it was 7 weeks. It was showing 75% increase in the life of the carbon, which is like a huge saving. So if instead of like every 4 weeks, you change your carbon every 7 weeks. That's going to be a huge saving. And as I mentioned earlier, this extended life that we observed in the AFRAS unit scrubber was because of, first we had the suspended media, which provided more surface area, and also because of the moisture removal mechanism, we made sure that the minimum amount of water gets into the carbon, which helps us to improve the life of the carbon. Future implications of city right now, after the successful pilot test of this technology, is planning to install one of the full-size units with this technology in Genesis site. So, since with this technology, with the smaller footprint, we can get a better performance, we decided to increase the airflow at Genesis site from 5,000 to 10,000. And often the result of even if the full size is successful, then we will replace all other carbon scrubbers in the city with the new technology. And now, if you have any question, I'm ready to.
I have a two-part question. So first, what's the maximum airflow that you would get through a single vessel? I tried to talk loud.
Thank you. Sorry about that. What's the maximum airflow that you can expect to get through a single vessel?
These the pilot ones or the actual full?
The actual full size.
It depends on the design, I think.
Okay, has that been identified yet?
Yes, the company that we're working with has a 5,000 CFM vessel. The company that we're working with, Amphasar, has a 5,000 CFM vessel designed for us. We have a 10,000 CFM facility that they have also designed a 10,000. And recently, because of a high pressure in our shoreline, we request to do 1,000 CFM vessel. Anything larger than that, we don't have any use for it, but on the ship they can access it.
Could you re-explain what you mean by suspended carbon? Is it fluidized and it's very fine powder, or yeah? Do you mind re-explaining?
Is the same carbon. The way it's installed is if we have a vessel, so it's suspended in the middle of the that vessel that we have. So I think
around here at that statement we don't understand what you mean by suspended. I suspect we're not the only ones here.
Can I answer that question again? This is the patented technology by AFRAS. I don't know how much of it I can express, but I tell you what we saw in the field. The media is inside the basket, supported with some structural member. So the air has the ability to travel under the vessel, and then they pressurize the vessel, air travel to all direction to the vessel. That's what we call suspended. It's not like this suspended at no force. I hope I didn't broadcast too much information.
Yeah, that's the patent that I'm not allowed to disclose.
At some stage, have you ever used just a traditional preheating of the inlet gas line to remove moisture? It seems that common practice in Australia to do that, rather than just trying to build a system with just an inline heater would remove all that moisture. I just think it's has that ever been tested at all?
I did get your question. Can you
okay, simple. Would you not use an inline heater of the inlet gas to dehumidify the air rather than this separation process and having to use a completely different type of...
You're talking about the dehumidification process?
Yep.
We already have that on all of the... Here,
yeah, right.
So on all our scrubbers, they do have a dehumidification. But even though we do have them, so some moisture gets into the medium. This is the additional layer of removing moisture. Yeah, we do have that thing in our today.
Hi, Hamid. 3 questions. Number 1 is has this test been replicated? So I saw you did this back in 2015, but has this test been replicated? That's question number 1. Number 2 is the carbon, you said that carbon breakthrough with the traditional carbon, is that a one-time occurrence or does it happen every single time with the traditional carbon? And the last question is the AFRA system more expensive or less expensive? How does it compare to just the coconut shell carbon media?
I think that 4 weeks, I think, is in line with our experience in other units that we have. Yeah, the life of the carbon in our scrubbers is 4 weeks. In any other unit that we have, every 4 weeks we need to replace it. That costs a lot of money. And then, what was the next one after us?
So the test has been replicated since 2015 every month, basically, right?
The pilot test?
Yeah.
No.
Okay, so it's only one time. Second question.
Based on that, yeah, we decided to go we get one full site and then test it on as a full site. Yeah.
Okay, and you're saying it's too expensive to run the pilot test again?
Why would we do it every month with the pilot?
Oh no, because of the when you're saying the breakthrough, and that leads into the second question. When you're saying there's a breakthrough with the activated carbon, with the traditional carbon, is that a one-time occurrence, or is that just it happens?
As I said, so this test, everything is same except how the carbon is in the middle. We use the same air, same carbon, everything is same. Coconut shell for both of them. The traditional one, after 4 weeks, we observed the failure, so it's not working anymore. So that's the breakthrough. So it means that we need to replace it. Same thing happens after 7 weeks on AFRAS. And then I don't know what.
No. The reason I'm asking is because in the beginning, you see that the differences is not that much, right? You're looking at about the numbers are about the same. After the breakthrough, you see a significant changes. So basing the results off of that, I'm asking if the breakthrough is something that just happens once, is it an instant occurrence, or is it happen all the time?
So
that's all.
You see the performance is 100% up to some point. As soon as we see it drop, that's the breakthrough. It means after that, it's not going to improve. So it's going to get worse continuously. Because the pore, as I mentioned, the way it works, the H2S gets trapped in the pore space. So either with the moisture or the H2S, the capacity is already taken. So it's not going to work anymore. So it's not going to, you see, maybe after breakthrough, you see it might come back to 100%? That's your question?
No, I think he was saying that does it always happen at 4 weeks for the traditional? I think I was saying that it does.
I'm trying to understand. Yeah, just trying to.
Yeah, I said this is in line with our experience because we have a lot of full-size units in the city using this technology. That's what we observe in other, is in line with that experience. That 4 weeks is the life of the carbon in this technology for us.
And we can have one more question, and then after that, maybe you can. We'll have 2 more questions.
Yeah, my question is,